Okay, let's check out a few logarithmic functions. In particular, we're going to look at the graph, but before we do that, actually, let's talk about like what is this, right? I mean, maybe you're new to what a logarithm or this ln is a natural log. Like, what does that even mean? So, if we have an inverse function, we looked at examples such as this. So let me go ahead and write function notation. Okay, right, 2 to the x power, that's an exponential function. But if we want the inverse, we have to interchange x and y. So let's write this as y equals 2 to the x, and then when we change x and y here, right, we'd have x equals 2 to the y. But up until we learn about logarithms, we really don't have a way of solving for y, right? When we do an inverse, we change x and y, and then we need to solve for y. So how do you get this y out of the exponent? And that's where a logarithm comes in. So you'll learn various techniques, but first off, by definition, this is a logarithm. So one way to think of it is a logarithm, y equals log base 2 of x, is the same thing as saying x equals 2 to some power y. Whoops. In fact, when I read a logarithm, because it's just not natural for us to think of this, I read it in this way. I read 2 to some power, so I kind of read it in an upwards motion. 2 to some power equals x. 2 to some power equals x. Well, because this is an equation, I have the answer right here, right? It's 2 to the y equals x. So we have two unknowns. Now, a natural log is just the inverse of the function y equals e to the x. Okay, that that exponential function, the e, has so many applications, so many purposes that we give it its own logarithm. Okay, we give it an ln rather than an log. The last thing I would like to say before we get into this graphing thing is if you check out on your calculator, you'll notice a log button, log. By the way, I always write log with a cursive L, that way it doesn't look like 10G. Right, that's the only reason. And in your calculator, you will notice a log button, and then usually you hit second or shift or something, and then you'll have ln. On a calculator, the log button automatically applies a base 10. So when we graph this log base 2x, the first example, we couldn't use a graphing calculator to get it exact the way that it's written. You'll learn a formula later, but for now, like, there is no way to do this that I have seen. I was told that some calculators actually you can change that base, but I don't recall which ones they are. All right. Anyways, let's begin this. So recall an exponential function. We'll go ahead and just do this table for this exponential that we have. Because an inverse, remember, we switch x and y. So I had created another video and we had a few values here. We'll just recreate those really quick. And we had 1/8, 1/4, 1/2, 1, 2, 4, 8. So log base 2 of x, let's change colors. If I do the inverse, right, f inverse, we have what we're going for, and this table then, remember we're changing x and y, so we would have x is 1/8, y is -3. X is 1/4, y is -2, and so forth. 1/2, half, -1. Let's just quickly write these. Okay, 1, 2, 4, 8. There we go. So in a graph, I'm going to go ahead and center it this time. Usually, we don't need to graph the portions that aren't necessary, but we're going to go ahead and do both. So our exponential, y equals 2 to the x, one key number we had was this y-intercept, 0, 1. And then we knew it had an asymptote. It didn't cross the x-axis. The line y equals 0, that was an asymptote. And it shot up exponentially quick, right? That is the graph of 2 to the x. So one thing we have learned with inverses is that they reflect across this line y equals x. Okay, so that's one way we can graph these. But we don't want to graph an exponential, right? We don't want to graph its inverse every time. I wanted to do this for the first one to show it does still hold that property. It does reflect. So we had the point 0, 1. Now we have the point 1, 0, right? That is a key point when we graph logarithms. And if we follow this, notice x, right? In the exponential, why we never got negative, right? This was always greater than 0. Well, because x and y changed, notice the x is always greater than 0. The x never becomes negative. So therefore, previously, we had y equals 0 as an asymptote. Now we have x equals 0 as a vertical asymptote. Okay, this line, this graph will never cross that line. And then the exponential shoots up very rapidly. Well, this shoots to the right rapidly because remember x and y interchange. This is the graph of log base 2 of x. Now, just like before, we have transformations, right? We could vertically translate it. We could stretch it. We could shift it horizontally. All those same rules apply. So all those same properties of the parent function, right? We take log as the parent function and we shift it and stretch it and whatnot. Okay, all those rules still apply the same. Looking at this y equals e to the x, we'll graph it really quick, but I will say this is, I don't know the powers of e in my head, right? If I did e squared for the original function, the exponential function, I don't know what e squared is. Now, e is approximately 2.72, so you could think of it really close to 3, right? So this is close to 9, maybe closer to 8, but, we would need a calculator for all of these values. E to the 1, even that, I'm rounding it 2.72. I don't know, it's a non-repeating, it's an irrational number, just like pi is. So I don't know all those digits. In fact, I think it's 2.71 something. Now, e to the 0, I do know. That is still an important point. So when we do the inverse, right, y equals ln x, we still have 1, 0. That's important to point out. The only thing that changes here is that these values are slightly different. Like when we did y equals 2 to the x, right? I'm saying e squared is approximately 9. It's like 8 something, right? So these values here are different, but it still has the same general shape. So when we go to graph this, the important point is right there at 1, 0. Everything else looks really close. Okay, if you were to get a graphing calculator and graph both of these, and in fact, like I said, you'll need to know how to change log 2x later. But if you just graph y equals log x versus y equals ln x, it will be very close. Okay, both of these graphs you would hardly notice if you were zoomed out.